Welcome to this fourth and the last video in the plenary session for Monday, March 16th in GRA6036. We are now to do exercise B from in assignment 3 from the final exam 2018. So go to its learning, and this is the exercise. So in this exercise, there are some data points in the background, and we are to suppose that we only know these four numbers. So the sample size, the second to last observation, the last observation, and the mean of all these observations. And we are to derive a formula for the n-2 first observations in terms of what we know. So this means that we want a formula for this in terms of these four numbers. So in other words, if we're given these four numbers in R, that we are able to compute it in R, so we shouldn't have any unknowns on the right hand side. So let's write down the exercise. So data, we have some data in the background. So these data are unknown to us. So but unknown, we only know the values of n, the sample size, the second to last observation, the last observation, and the mean of all the observations. Okay, so this is what we know. And so now we should find a formula for the mean of the n-2 first observations. So it can be helpful to write down what this is. So using the standard formula for this is when we have a bar across the axis. That's our standard notation for the mean. So this is then the mean of the n-2 first observations. So it's this. Now, to derive such a formula, we can start by writing down. There are probably several different ways of doing it, but one way is to write down the mean and then take out what we know. So the mean is 1 over n, and then the sum of all the observations, which is this. And then we can use the definition of a sum to see this more clearly. So we have this is an x1 plus dots all the way up to x minus 1 plus x and the last observation. And the reason for writing it like this is because these two numbers we are given. So now you see that we can write this thing as, so we have the sum all the way. Maybe we should write like this even, with inequality. And now you see that these first x's, these ones, we can use the summation symbol for these. So then we start counting at 1 and we count all the way up to n-2 xi. So this then takes care of these multiplied by the constant that's outside, and then we multiply this constant outside by these last two observations. So we get plus 1 over n x n minus 1 plus 1 over n x n. Now we see that we are, since here we have this sum, so we're close to getting this mean. So a trick then to get this mean is to multiply this by 1 in the correct fashion. So if we multiply this term by 1 by doing this, then we have an equality here, and now we see that this sum multiplied by 1 over this is this mean. So to make it even more clear, we could move this n minus 2 here over here. And now we see that this is the mean of the first n minus 2 observations. So we replace this by the symbol right here. So then we get n minus 2 divided by n times the mean of the n minus 2 first observations plus these last two terms that are known to us. So we get this. Now, notice now that this is known, and the left-hand side here is also known. And this fraction here is known because you know n, and this is what we were supposed to find an expression for. So now we can move things over. So move things around, and we now want this, the mean of the first n minus 2 observations on the right hand side. So then this must be equal to the mean. Oh, so then this is equal to this one minus this term minus this term. So we get 1 over n x n minus 1 minus 1 over n xn. Now we can multiply by n divided by n minus 2 on both sides to get an expression for the mean of the n minus 2 first observations. So we multiply by n divided by n minus 2 on both sides, which then if we multiply this by n divided by n minus 2, that's 1. So then this first here disappears. And then we have to multiply this mean by n divided by n minus 2. So we get n minus 2 here. And then so we get this. And then if we multiply this by n divided by n minus 2, then this goes away. So we get n minus 2, and the same thing here. So we get this, which we might write even more, which we might write as minus 2 and then some parentheses. And then that's the mean, like this, minus x second to last observation minus the last observation. And we have to remember to multiply this by n. So we get this. Now, here we have an expression for the mean of the n minus 2 first observations in terms of what is known to us. Recall that these four numbers we know, which means that n minus 2 is known to us, n is known to us, the mean of all the observations is known to us, the second to last observation is known, and the last observation is known. So we are now done the exercise. Okay, so we'll talk soon.